Let's continue looking at the different aspects of graphs of functions. We looked at the vertical line test. We looked at finding domains and ranges and function values. We looked at finding zeros. Now let's look at intervals of increase, decrease, or constant. So we're going to be finding these intervals by moving left to right along the domain. So we're going to move left to right, and we're going to use interval notation. Since we're trying to find open intervals, that's the definition, we're going to always use parentheses. So for any of these increase, decrease, constant intervals, there will be no brackets involved. So let's go back and remember how we do interval notation. But let's first trace this graph going left to right. So if you put your pencil on the leftmost point right here, as I go left to right, notice it's constant, then it turns to decreasing, then it increases, then it's constant again. So I've got a constant interval, a decrease interval, an increase interval, and another constant interval. So I need to write those intervals using interval notation. So this constant interval, because there's an arrow at the end, means it starts at negative infinity and it stops being constant at the negative 3. So a constant interval is negative infinity to negative 3. We only use x values because we're moving left to right. So we look at domain values only. So there's a constant interval. Notice no brackets. All right, for my decreasing interval, it starts right here at negative 3 and stops decreasing at negative 2. So negative 3 to negative 2. No brackets, and the smallest number goes first. Increasing starts right here at negative 2 and stops up here at positive 2. X values only. So negative 2 to positive 2 would be an increase. And then finally, I have one more constant interval that starts at 2 and stops at infinity. And so that was another constant, so it's going to be 2 to infinity. So this describes what happens with the graph with respect to increasing, decreasing, or constant. We may sometimes have to put this symbol, this U symbol, between two intervals when there's more than one interval involved. So I think in WebAssign, I'm not sure if you have to or not, but if that symbol is available, you have to use this union symbol. Okay, so increase, decrease, or constant. How about we graph one and then determine the intervals of increase, decrease, or constant? So let's practice graphing again. I'm going to pull this up. I'm going to go to y equal and clear out what was in there. And I'm going to type in my x cubed. I'm going to use the caret to the third power. Use my arrow to bring it down. Plus 3x, and that's a square. I'll bring it down from the exponent. Then I'm minus 1. And when I graph it, I'm always going to go to zoom 6 to make sure I have a standard viewing window. And I can see if I trace this graph, it's increasing, then it's decreasing, then it's increasing. Okay, so it's going to increase from negative infinity, or actually, let me just say this, because this is continuing on down to negative infinity. I'd have an infinity and an infinity here. This one's going up to positive infinity, so I'd have an infinity and an infinity there. So let me just try to, let me take a second and repeat that graph over here. Actually, I think I can do this. Okay, give me a second. Come on, close down for a second. What? All right, can I just do something like this? I'm going to hit OK. Yes. Oh, damn. Didn't want to do that. Pause. Okay, I was able to successfully get that graph here on this document. Now, taking a look at it, let me get my pen back. Okay, so since it's going to infinity, I would have negative infinity, negative infinity. Over here, that arrow tells me infinity and infinity. So as I go left to right, it's increasing from negative infinity, because it's down here at negative, to the left at negative infinity, and it stops increasing right here at negative 2. Then it decreases, and it starts decreasing right here at negative 2 and stops at 0. But then it increases again, and it starts increasing at this 0 mark and stops at infinity. Put the union between those because I have more than one interval. Notice there are no brackets. And the smallest number always comes first. Okay, so increase, decrease, constant. I might want to know where are some maximums and minimums in my graph. And on this one that we just did, a maximum occurs kind of like at the top of a hill, like right here. That might be a relative maximum. And minimums occur at the bottom of a valley. So right there would be a relative minimum. So those are some important points that we'll want to know about our graph. So maxima and minima are points where the function changes from increasing to decreasing or vice versa, are basically our hills and valleys. Top of a hill, bottom of a valley, I have a relative max here and I have a relative minimum here. What do those ordered pairs look like? Well, this one looks like it's at 2, probably negative 14. And this one looks like it's at negative 2, probably 18. So those are the, oh, sorry about that. Those are our relative maxima and minima, a hill and a valley. So this maximum value occurs at negative 2, and the maximum value is 18. So it occurs at negative 2, and the highest it goes is 18. The minimum occurs at 2, and the minimum value is negative 14. I'm not sure how WebAssign asks for this. They may just ask for the ordered pair. So you would type in 218, negative 218, and 2 negative 14. But we got a max and a min. Okay, let's keep going. Oh, we want maxes and mins. Let's practice on our calculator. So let's pull that thing up again. Let's go to y equals and clear that baby out. And I need an equation. Minus 4x squared minus 7x plus 3. Minus 4. Let me just make a note. If you have to make something negative, you must use this little negative symbol right here, not the subtraction symbol. So the negative I used before I typed in the 4, so that made it a negative 4. All right, so I'm going to go to Zoom 6 and graph it. Aha, got a parabola. And that parabola is opening down. Therefore, I see I have a relative maximum. I've got a hill right there. So where does that maximum occur? Looks like it's at negative 1. I could estimate it, but let me show you a cool trick to find it exactly. Go to second calc, and you'll notice there is a maximum option. So press 4 for maximum. And the calculator is going to ask you to move your cursor to the left side of that hill. So left bound means move your cursor to the left of the hill, press enter. Right bound says move your cursor to the right side of that hill, press enter. And notice you get these 2 lines where your maximum is going to be, and when it says guess, press enter again, and it tells you exactly where that maximum is. This is an excellent skill that you want to be able to use as we go on in this course. Going to second and trace and using that calc feature. So we found the maximum, and whatever that ordered pair is, that is our maximum. So what does it look like? Negative 0.875. Negative 0.875. This is an ordered pair. And 6.0625. That would be our max. So going back, all you have to do is go to second trace, which gives you the calc menu. And in the calc menu, we can find zeros, we can find minimums and maximums. So excellent feature. Okay, this section has a lot of information in it, as you've already figured out. Working with graphs of functions, let's determine if a function is an even function, an odd function, or a neither function. Knowing that will help us understand what happens graphically with the symmetry. So an even function has its symmetry with respect to the y-axis. So you look at the y-axis and see if you have symmetry across the y-axis. Then it would be an even function. Odd functions are symmetric with respect to the origin. That means across the origin, you have symmetry if you look across the origin. Okay, so let's look at these graphs and determine what kind of symmetry they have, and then that'll tell us if it's even, odd, or neither. Okay, so looking at this first one, I noticed that across the origin, if I folded my paper right here along this dotted line, the graph in quadrant 1 would overlap the graph in quadrant 3. This is an odd function because it has symmetry across the origin. Looking at this guy over here, this parabola, if I folded my page right here along the y-axis, the parabola would overlap itself. So it is an even function because it has y-axis symmetry. And then looking at the last one, I'll look to see if it does the same thing across the origin. Nope. Across the y-axis. Nope. So this is neither. So even functions have their symmetry with respect to the y-axis. Odd functions have their symmetry across the origin. Let's look at the graphs of these functions to see if we can determine if they're even, odd, or neither. So I took the time to put all three graphs under y equal, and then when that equal sign is highlighted, that means it's the only one it's going to graph. And you can toggle those off and on by just arrowing over to the equal sign, press enter, and that'll turn it on. Or if you want to turn it off, do the same thing, press enter, and that toggles it off. So when I press graph, I'm only going to see the graph of one function at a time. So the first one looks like this. Looks like I've got symmetry across that y-axis. And I might want to zoom out a little bit just to see what happens a little bit further down. So let me zoom out. Okay, yeah. So I've got symmetry across the origin. So this guy would be an odd function. Okay, but I'm going to go back to Zoom 6 because that's the window I want to always be in to get started. Let's look at the second one I typed in. So what I want to do is turn the first one off and come down here and turn the second one on. That highlight tells me it's on, and let's graph him. Aha! I see the symmetry across the y-axis, so that's an even function. And my last one, I'm going to go to y equals. I'm going to turn this guy off and turn this guy on. And let's graph him. Well, I don't have symmetry across the y-axis because it's scooched over a little bit, and I don't have symmetry across the origin, so this guy would be neither. When we think about the symmetry, if it's an even function, remember the symmetries across the y-axis? So I'm going to draw a little graphic of this right here. If I had the point -4, -6, it would be down here. And if the symmetry is across the y-axis, because it's an even function, I would have another point on this side that would match him. What would this point be? +4, -6. See if you can figure out this other one. It's an odd function, so it has symmetry across the origin. See if you can figure out another point on that graph if you've given the point -3, 5. What would be another point on that graph if it has symmetry across the origin? It would be over here, which would be +3, -5. So this answer would be 4, -6. This answer would be 3, -5. Because of the symmetry across the y-axis, that's our other point. Across the origin, there's our other point. I'll stop this video with this. It'll continue. We'll have one more video that goes with this section. If at any time you have questions, please email me. I am happy to help.